Okay guys, so we're up to around 17 generations, and let's have a look at what result Octopus is giving us. Let's select a solution that is kind of equal parts minimizing the amount of points where the radius is more than 4.76, and also trying to minimize the total difference. So let's reinstate the solution, and And here we go. This is what has resulted. This is there's quite a bit of difference you can see in the curve here. However, it is performing, pretty well. However, that difference is still quite large, and I might want to let that run for quite a few more iterations. Hey guys, so I've let this run for quite a few hours actually. Packed up for the night, and I went and watched Speed, which was pretty awesome. Don't know if you know this, but it's a movie about a bus that can't slow down. It's got Keanu Reeves in it, Sandra Bullock. I would highly recommend you guys watch it if you haven't. But anyway, while I was watching Speed, I let my optimization run, and if you remember from the last video, I sort of specified these more these preferred iterations, and what that did was Octopus would go, all right, let's try and make things that are similar to this, but also that perform better as well. And you can kind of see here, I've let this run for 103 generations, and I can actually step back in time with them if it'll let me. Sorry, when you start to have quite a lot of data in Octopus, it does slow down your machine quite a lot, so it could fail at any time. Okay, so here we are. You can see even at Gen 73, it's starting to get quite a few results that are approaching zero numbers of points where the radius is 4.76 or smaller, which is great. And then I guess once we're there, we just start to try and optimize down that number 65.78, which refers to the difference in curve. So ideally you want as lower difference as possible. And when my computer loads it, I will show you some of the more optimal results that we got out. Okay guys, so I think we're finally loaded back to our original generation. So I'm going to reinstate it, and let's have this is supposed to be one of the most optimal solutions, after 103 generations of 200 results. It's quite a lot of results to process, and along with every other program that my computer's got on currently, it's quite a slog to get it over the line. But I guess while we wait for it to work, I have to remind you guys to hit that like button if you like the videos and want to see more of them. It's like the old little kick in the ass for me to pull my finger out and produce good content for you guys to help your learning. And in any second now, we're going to be able to like view Grasshopper properly, because it would have loaded properly and my computer would have got a little bit more life breathed into it. Alright guys, let's have a look at that now that it's loaded. Okay, so you can see straight away we've got something that, you know, matches it mostly, and you know the difference is 7.5 mil on my own metric, and you can kind of see there is a little bit of deviation here and there, but by and large it is pretty good. And of course we've got 0 points along the curve where the radius is more than 4.76, which is great. So yeah, so that was, you know, like I did this like once I got a good result for this curve, I literally like ran the same optimization run on this curve and this one and another one as well, and then that's how the joint came about. You know, there you go, there it is. Maybe this is like an older version, but you know, that's how it came about. And yeah, so I'll try and do a few more other videos on Octopus and what you can do with it, maybe in a more architectural sense. But again, this is like a really, really small problem. But you know, through using multi-objective optimization, I managed to solve it quite well. So I'll leave it here, guys, and I'm gonna go maybe make some more content or go enjoy the rest of my afternoon. So yeah.